Hi everyone. Today I'm going to talk about derivatives of the calculus, and this video is a part of the Com 533 modules in University of Liverpool. So let's get started. So to explain the derivative, I present about three rules that may be useful for calculate the derivative. The first rule is about the power rule. Power rule is about to bring down the exponent as a factor and then reduce the exponent by 1. So, and if fx equal to x power n, so then the derivative of function x equal to n times x power n minus 1. So let's move on to the example to make it clear. For the example, to find the derivative of functions x power 12. So the 12 is, the n is equal to 12, so we can use 12 times x power 12 minus 1, and the result is 12x power 11. So let's move on to another rule. The other rule is called the constant manifold rule. Constant manifold rule is to differentiate the product of a number k with fx multiply the number k by the derivative of function x. So the derivative of function k times fx is mean we can pull out the number k outside the functions, and we will multiply it after the differentiate process. Let's move to the example. The example showed about to find the derivative of the minus 3 times x power 7. So it can be pulled the minus 3 out of the differentiative process. Like we consider the differentiative of x power 7, and then the result will be minus 21 times x power 6. So the last rule is about the sum rule. Sum rule is to take the sum of the different derivatives. If we have to consider about to find the derivative, the sum of function f and g, we can find the differentiative of function separately, like find the derivative of function f and then sum the derivative of function g later. And it's another formula of sum rule. So the example of the sum rule is to find the derivative of 4 times x power 9 minus 6x power 5 plus 3x power square. Sorry. So the solution is to use the sum rule to separate in each functions, and then use the other rules like the power rules to find the derivative of powers, and the constant manifold rule to pull out the constant. And then this is the result of the function x is equal to 36 times x power 8 minus 30 times x power 4 plus 6x. So from the previous example, the derivative of the polynomial look like this. It can be found which use all the rules that I mentioned before. Like this, use the power rule to find the derivative of powers, to use the constant manifold rule, and also use the sum rule as well. So what are the second and third derivative of example 3? The example 3 is the function x equal to, it look like this, and we already obtained the result of the first derivative of function x. To find the second derivative, we have to use the previous derivative result to find the differentiated of the next different derivative. Like this. This is the result of first derivative, and we use to find the next derivative, the first derivative to find the second derivative, and the result will be like this. And if we have to find the third derivative, we will use the result to differentiate and find the third derivative, like this. Use the result of the second derivative and differentiate them and give the result. And that's it. Summary. derivative of a polynomial phi by combination of power rule, constant multiple rules, and sum rule. To find next derivative, by differentiating the first derivative, we obtain the second derivative. By differentiating the second derivative, we obtain the third derivative, and so on. So, thank you for your listening.